A very good day to all the top management. We are from Group 15 and we are in charge of the tablet named Tiew Lajak Kuruih O. We will explain the tablet manufacturing and analyze the status of production. My name is Tiew and I will summarize the data.
My name is Moon Sheng Hin and I will comment on whether there is significant evidence that the tablets produced do follow the normal distribution.
My name is Edmund Vukayong. I will be commenting on whether there is any significant difference between the tablet weight from the different shift.
I'm Vincent Tanida. I will present about the prediction of the tensile strength at a low relative density and comment on the validity of the model that used for this prediction.
Let's start with the summary of sample data, which is the dataset Tiew Lajak Kuruih O. From the dataset, there are 4 categories or 4 fields, which are weight in unit milligram, relative density in percentage, tensile strength in megapascal, and also shift. The data is grouped into these 4 categories so that we can analyze the data easily later on. For graphical form, I have summarized the data into 3 different graphs, which are bar chart, scatter diagram, and also pie chart. For bar chart, we can clearly see the distribution of the weight. It actually follows the normal distribution, where the shape of the graph is likely a bell shape. The next one is the scatter graph of tablet hardness. Studies have found that the tensile strength of the tablet depends on the relative density, and these 2 variables can represent the hardness of the tablet. From this graph, we can get a trend line and see how all these points is scattered from the trend line. The less scattered the point indicates that the linear relationship between tensile strength and relative density is getting stronger. This is actually related to the sample correlation coefficient R, which we will discuss later in part D. The next one is the pie chart of production shift. From here we can see the fraction of each shift, where for morning shift is 32%, for evening shift is 33%, and lastly for night shift is 35%. Next, for numerical form, we can get some information from the data by using Microsoft Excel, such as mean, median mode, standard deviation, and so on. We are informed by the Food and Administration FDA that the weight of the standard tablet produced should be normally distributed with mean of 350 mg and standard deviation of 40 mg. From this table, we can see that the mean and standard deviation of the weight is actually quite close to the requirement. That's all from me. Let's continue with the next one.
For question B, the Food and Drug Administration Authority requires the weight of standard tablets produced by manufacturers should be normally distributed with mean 350 mg and standard deviation of 40 mg. So we are required to comment on whether there is significant evidence that the Lajak Kuruih tablets produced in December 2020 do follow this distribution. So first, we construct a frequency table by the data given for the Tiew Lajak Kuruih O. Then, from the question, we are given that the sample size is equal to 200 and the mean weight 350 mg, standard deviation 40 mg. So in this case, we assume that our X is the weight of the tablet, and we also let this level of significance alpha is equal to 0.05, and our hypothesis statement Our decision rule is to reject H0 if the chi-square test is greater than chi-square alpha v. And this is our chi-square test formula. For normal distribution, our H is converted to Z by using this formula, where Z is equal to H minus mean over standard deviation. And this is our constructed table, the Z calculated from H, and our probability taken from the statistical table. And this is our observed value, which is same with the frequency. And this is our EI. Since our EI must be greater or equal to 5, so you can see that here is only 3.2124 and here also the same. So we have to combine these two and these two together. So after we rearrange the table, we get 7 plus 4 equal to 11, and 11 plus 6, 17. EI also combine. So the total of this value, 6.136, is our chi-square test. From the statistical table, chi-square 0.055 is equal to 11.07, where our chi-square test is smaller than our chi-square alpha v. So we fail to reject H0, and we can conclude that at alpha is equal to 0.05, there is a significant evidence that Lajak Kuruih tablet produced in December 2020 do follow this normal distribution.
Good day everyone. I will now be commenting on whether there is any significant difference between tablet weight from the different shifts. Since we have 3 shifts, which is morning, evening, and night, we will have to use a one-way ANOVA analysis to analyze this data. Before we do that, we will have to sort out the data into morning, evening, and night. Using the Excel sort tool, we can sort out this data. Using this data, we can run the Excel one-way ANOVA analysis and we will get this result. In the hypothesis statement, if we accept HO, it means that there is no significant difference between the 3 shifts. If we accept H1, it means that there is a significant difference between the 3 shifts. In the Excel ANOVA analysis, we will get this result. In it, we will see the summary. We can see the morning, evening, and night. The count for each group is different. The total sum, this is the total sum for each group, the average for each group, and the variance for each group. In the ANOVA analysis, we will get the SS, which is the sum of square, DF is the degree of freedom, MS is the ratio between SS and DF, and we will get the F value, P value, and F critical value. We can conclude this analysis by using the F value and F critical value. Since the F calculated value, which is this one, equal to 0.532352, is less than the F critical value, which is 3.04, we cannot reject HO. This means that we can conclude that at alpha equal to 0.05 level of significance, there is no significant difference in tablet weight from the 3 shifts.
Here is me, Vincent, who will present to you about the question D. Based on the current data in December 2020, a prediction will be made to find the tensile strength for the lower relative density. So, by using the method of least square of a simple linear regression model, an equation of y hat equal to alpha hat plus b hat times x is made. The y hat is represent the tensile strength and the x represent the relative density. Here is the summary of the output by Microsoft Excel with the data analysis of linear regression. From this output, we can find the coefficient of alpha hat and the beta hat from here. So, the alpha hat will equal to negative 0.10932 and the beta hat is equal to 0.08184. A new equation will be obtained here. So, to find the tensile strength at the relative density of active egg percent, 74.3% and 80.1%, we just sub this value of x respectively into the equation. So we can obtain the value of tensile strength equal to 5.4563 megapascal, 5.972 megapascal and 6.4467 megapascal for each value of relative density respectively. From the output summary of Excel also, we can obtain the value R and R squared. From here, the multiple R and the R square, where the R will equal to the 0.x47719 and the R square is equal to 0.71x627. From the value R, it is shown the strongly positive linear relationship between the tensile strength and the relative density. This is because the value R is a positive value and it is close to the value of 1. In the other hand, to comment on the validity of this model of prediction, we use the value R square. The value R square also called the coefficient of determination and is often used to check the adequacy of the regression model. In our case, the R square means there is the 71.86% of the original uncertainty in the value of tensile strength can be explained by the straight line regression model. Since the percentage is higher than 60%, thus the SLR model is considered adequate and it is valid. So here is all for the question D. Thank you.